Silent nights recalling you, a souvenir of what it could be. Pieces of my mind are yours. I forgot the parts I'm missing.
Welcome everybody. So today we're gonna talk about. First of all, can you guys hear me well and see my screen?
I can hear you pretty well, yes, and I can see your screen as well.
Okay, that's great. I assume that's a yes for everybody as well. So we're gonna talk about AWS and how to deploy an IceVision application on AWS. So for the ones who don't know me, so I'm Francesco. So I'm a machine learning engineer at Faction, a Belgian startup in the AI domain, and I'm having a lot of fun with deep learning right now. So I guess it fits the purpose quite well as well. So this is the little plan for today. So I'm going to start with how to showing like a working web application. So VisualNeurons.com, that's the website which I like put together a couple of years ago, in which I deploy my models, just like to showcase them. And then we're gonna dive into the actual meat of the presentation, which is the serverless architecture, right? So specifically in the AWS ecosystem, that's Lambda, so Lambda functions. So what is a Lambda function? How we trigger a Lambda function, and how do we go from a web browser, so a client front end to the back and forth without having like to go through the headache of servers. Then, like to make things a little clearer, we'll implement a very simple Lambda function from scratch and invoke it with an API gateway, and then start talking about how to build up a little bit in complexity. So how do we add libraries to the Lambda environment? Because we'll realize that Lambda is awesome, but not so awesome. So we might need to add libraries which are not there, and we'll investigate two ways to do that: Lambda layers and specifically the announcement which was made a couple of months ago, which is Docker support for Lambda, which to me is kind of the game changer in the serverless ecosystem on AWS. And then as an optional point, seeing how we're gonna do with time, we'll also check out how to train models in SageMaker Notebooks plus Studio. I also think it's kind of interesting, especially for SageMaker, to check cost. That's something which is frequently overlooked, and if you don't pay attention, you can go bankrupt pretty easily on AWS. All right, so let's move to what this is all about, and specifically. That's me testing stuff before. So what I wanted to start from is the end. So it's the product, right? And then we kind of work backwards, right, from the final product to how it was built up. I guess it's more interesting than starting from from the bottom and building up. I would like to do the opposite. So here we are on VisualNeurons.com, which is, as I said, is a domain I purchased a couple of years ago to kind of deploy models, showcase and test stuff on my end. So we're gonna check out a couple of those applications, and the one I wanted to test first is of course, is the IceVision one, right? So this is an application I worked on last month, and basically the whole purpose of it is to pass scribbled math, so handwritten math, on a piece of paper to the model, and then the model will run an object detection on top of that image and recognize LaTeX symbols, right? So it will not spit out an actual fully working related syntax. That's the second stage of the project, I'd say. But now, for the time being, it will just ingest the image and then figure out where first of all, where the symbols are and how to convert them to LaTeX. So let's check this out. So we're gonna input this guy. That sounds reasonable. And then we hit extract LaTeX. So this takes a little while. So if you run it for the first time, it takes quite a while due to the so-called cold start problem, which we'll talk a little bit about later on. In a nutshell, as we'll see when we dig deeper, the problem is that we don't have a server running in the backend, and so AWS needs to spin up a new one just for you for the very first time when you invoke it. So it will take it takes a while. Then generally, when you invoke a lambda function multiple times after the first, it is a lot faster. Now, as you can see, like my implementation is definitely a little slow. I should make it faster, but the purpose was definitely not to deploy fantastic and super snappy model. So in the backend, oh yeah, this is done by the way. So as you can see, the model figured out like where the symbols, the math symbols are, and correctly identified them, right? So I think it's kind of cool. So we can pick another one. This one. So like the first one I showed you, that's coming from the validation set. This is myself writing on a piece of paper. Hello? Right. This is myself writing on a piece of paper. So hopefully that should work as well. So let's see.
Alf, can you mute yourself, Alf? There is a little bit of background noise coming from your microphone.
That's myself?
No, Alf.
Oh, okay. All right, so that's it, right? So as you can see, it's kind of magic, like it's really cool. So we click a button and everything is working, right? Hello, please go on mute if you can. that would be really cool. Now let's track this down, right, and understand how this is working in the backend. And to do that, like let's go to developer tools, and let's check this out. Well, everything happens. Like the magic is triggered by this button here, right? So this is this guy. Nope, sorry, this one. All right. So this is the ST button. Don't ask me why I called it ST. It's a very bad name. But anyway, it's ST. And so let's see what happens, right? So ST is linked to this onClick function. All right. So the onClick function. So upon clicking that button, what happens is that we basically pack the data, like the image, which is stored in the math_image canvas, which is this one. So that's the input, right? So we basically get the input. We pack it into, we convert it into base64, which was formed into a JSON payload, and then we send this payload to a post request via post request to a REST API to this endpoint. Okay. So this endpoint specifically. All right. So we'll check in a minute what this endpoint is. But anyway, so then the rest is pretty simple. Upon success, we process the response, which is nothing else than basically getting the source of the LaTeX image. LaTeX image is this other canvas over here. So that's where the output is. Where is it? That's the one, right? LaTeX image. So what we do is that we basically populate the source of that canvas with the response from the API. Okay, so easy peasy, really simple. Now, that you might say, okay, so the entire magic is actually happening under the hood within this API, right? So what is this? So to check this out, we'll have to investigate what API gateway is. So this is like our first interaction with AWS, right? So again, we're building like the process from the end, like to the beginning, building one step at a time. And the second step after the client, so your front end, is checking out the API. API Gateway is a service from AWS which allows you to build very easily and very quickly REST APIs without having to go through the fuss and hassle of doing that yourself, coding that yourself. So specifically, the API I'm talking about is IceVision. So the IceVision API. We can check that the endpoint is actually that one, and it is, right? So we're actually invoking this guy, right? When we send to AWS the payload through with the image, we're actually invoking this API over here, and this API is composed of a post method, which we know all about, right? Which, as you can see shown from this chart, is doing nothing else than redirecting your request to a Lambda function. Okay, so we don't know yet exactly what a Lambda function is. We are getting here, but basically the role of this REST API is nothing else than redirecting your request, so getting like the payload and sending the payload to this function. Then the function does its magic and then returns the response, which is then as we saw, it is then incorporated in the UI, so on the front end. We can click on this guy and check out now Lambda, right? So here we go. So this is the Lambda function which we are calling, right? It's as you can see, it has this so-called in the AWS jargon, it has a trigger, right? It is triggered by API Gateway, which is nothing new. We already knew that. So API Gateway is triggering IceVision LaTeX, so this function. And then as we scroll down, it's a little disappointing here, right? Because we don't have code, right? So which kind of code are we running, right? So what we see is that there is a Docker image which is linked to the to Lambda function, and we'll get there a little bit later. I don't want to spoil it too soon, but if your first interaction with Lambda, it could be a little disappointing, right? So there's no code, everything is hidden. So what the heck is going on? So I propose that in order to make this a little bit clearer, we implement a Lambda function from scratch and see how this works. Okay. So all right. So let's do that. So we create a new function. We order from scratch. We call it demo. We want to use Python 3.8. We need to find the execution role for permissions. So I'm going to use an existing one. Hacking Lambda. Yeah, that sounds like a good one. And then I create a function. All right, so that's it. So as you can see, okay, now this is a little different, right? Because we authored from scratch, so we are not using like any Docker image like to build our function. So now it's a little bit more clear what at least like the code which we're going to execute. So Lambda is kind enough like to pre-populate the lambda underscore function.py file, which is what is getting actually invoked. So actually, to be clear, the lambda handler function is what is getting invoked. Okay, so I propose that we edit this one a little bit to make it a little bit more interesting. So I have, as you can see, an incredibly sophisticated way of logging what I do, which is copy pasting everything crossing my mind into stuff.py, and then we copy paste here. Okay. Yep. So deploy. All right. So now this is the function, right, which is getting invoked. Let's check this out, right? How do we know if it is working? So the way to do that is to, test it. And Lambda makes it really easy to do that. So we do that like this. So we say body, and then we call Francesco, and then create, oh, yep, that's right. demo. Create. Okay. So as you can see, like the function is really, really simple, right? So we import JSON, then we're gonna print the event. You'll see why we print the event, but anyway, so we just read like the JSON, and then we print something, right? Nothing fancy. And then when we hit test, oh, good, that's cool. So we get hello from Francesco, which is exactly what we were expecting, and we also get the body, which is printed. Now, let's stop for a second and think about what we just did, right? So what we did is the following. We executed this piece of code, which is a Python 3.8 code, nowhere, basically, right? So where this is running, right? That's the question you should be asking yourself, I guess. At least that's what I asked myself when I stumbled upon Lambda for the first time. And well, that is the entire purpose of Lambda, right? So it's running on a server, of course, right? Because it cannot run out of thin air, but you don't see it, right? That's the entire concept or the entire pillar of the serverless architecture, right? So you click a button, in this case, test, and AWS is taking care of spinning up an EC2 instance. An EC2 is basically just a virtual machine for in the AWS ecosystem. Is taking care of having all the libraries installed, Python 3.8 installed, and then it's calling that function for you. So you didn't have to do anything like that, right? Normally, another way, like the standard way of invoking this function would have been to go into AWS, fire up an EC2 instance, select the operating system, and then select installing the library, and then SSH into the virtual machine, installing the libraries, and then creating a little script, right? Lambda function.py, and then calling Python lambda function.py and getting the results, right? So that's how we would do it. For Lambda, there is no need to do anything like that, because again, AWS is taking care of the servers for you. So this is a real game changer, right? If you think about it, because you are completely exempt from the hassle of taking care of all the backend for which is normally should be done in a standard project. So the benefits are clear, right? So you don't have like to take care of security patches. You don't have to take care of the server altogether, right? Which means that there's no downtime. You don't have to figure out that okay, is my server up and running? No need to do that. Servers will be always up and running because AWS is taking care of them. Scalability, right? You can call millions of those functions, right? And AWS is going to take care of making sure that those functions gets executed. Of course, you're gonna get billed, right, for those. That's obvious. So it is incredibly cheap to run on a serverless architecture, on a Lambda architecture, because you get billed just for the execution time, and I think it should be in the milliseconds, literally. So this guy ran for 1.43 milliseconds, and I'm gonna get billed for 1.4 milliseconds. That's it, right? That's what I'm gonna get billed. On the contrary, if I had a server running, up and running 24/7, well, I would get billed for a server being up and running 24/7. Well, you might ask, well, does that mean that people using servers are dumb? Not really, because of course, as soon as you increase the volume of requests which are being handled by Lambda, at some point the bill the Lambda bill is gonna overtake an EC2 bill, like a standard server bill. But again, so it's for low volume sporadic traffic applications. That's really what you should be using, and that's why I use it for VisualNeurons.com, because I have one user per day, which is basically me, and so I really don't want to have like a server running 24/7 just for that. I didn't specify that at the beginning, but I tend to talk a lot. So I apologize for that. If you guys have any questions, just shoot.
I have
Just
a
start yell.
I have a little question. So with Lambda, do you get to specify what type of machine you want? Because what I'm thinking is some applications might require a machine with a lot of RAM. Some other applications might require like a small machine. How does that work?
You don't get to specify that. You get to specify the amount of RAM you want. So in here, you see you can edit. So you can go to up to 10, 10 what is that? No, 10 gigs. Yeah. So it's pretty big, right? No, that's one gig, whatever that is. Like it's so a pretty decent RAM, but you got to specify it, right? So you can specify the RAM and also the timeout. So by definition, your Lambda function can run for up to 15 minutes. So if you have a function which runs for more than 15 minutes, it's gonna time out. So that's something which you have to take care of yourself. But RAM, as you said, it's definitely something you can select here. You don't get to choose the machine. So in terms of the CPU, that's something as far as I know, like AWS was working on, because I was in touch with AWS evangelists and asking for GPU support. Right, it would be awesome to have GPU support for example, like style transfer. Right, that was my
Yeah, yeah,
that was
imagine.
my
It was really cool.
application.
Mhm.
And of course, you cannot run a loop like in the standard style transfer application, in which you have to run a loop, right, n hundred times. You just cannot do it on a CPU, right? It's gonna take way more than 15 minutes. By GPU, it takes 1 minute probably, right? But GPU, it's not supported right away for the time being.
I see, I see.
I have a little question. The endpoint, the address of the endpoint, I guess it stays the same
Mm-hmm.
as
Yeah,
long as you have your Lambda defined
yeah,
with their
yeah.
service.
Well, those are decoupled, right? So like, wait, are you talking about this guy?
The endpoint that you showed at the beginning,
This one,
where
like the post, the one which you are the REST API
yes, that you showed in with the HTML. No, not in the HTML. At some point you
in
showed.
JavaScript.
I think so.
Yeah. Yeah. So if you're talking about so this guy,
Yeah, that one. Yeah, API endpoint.
API endpoint. Yeah, yeah, yeah. This is like API gateway. So this is you're gonna get it from here, and this is it stays the same. I mean it's coupled to your API gateway service.
Okay.
So actually, let me do that. Let me create a now that we have like a very simple function over here. So let me create an API gateway so that we can trigger this function, right? Because of course, like this is all nice, but then it's completely useless, right? How do we call this function? How do we execute this function, right? That's the question. And
So
the question is that
just another question here that I think fits. When you did a little test there on your
yeah.
Lambda, the test is basically what the API gateway is going to give to Lambda. Is that it?
Well, not necessarily, but it should, yeah. But I mean, it's your responsibility to wrap like the code as you think it should be wrapped, right? So, for instance, I mean, in theory, yes, I agree with you. Yeah, yeah, it should be like in the same format at least as your Lambda is able to accept, right? So in this case, I specifically have like a body here, right? So if I'm gonna do something like this and whatever like payload, this is gonna fail, right? Because it doesn't know what payload is,
I see, I see. Makes sense, makes sense. So in the
right?
API gateway, I have to follow basically the signature that Lambda expects.
Yes, exactly. Yeah, you have to wrap it, but that's also like on your client side, right? So what I know is that I have data here, right? So I'm sending like a payload with this kind of like with a JSON and then and this kind of key value pairs. So I need to know that my Lambda expects data, right? At least in this format, right? So yeah, you have to know that in advance, or at least you can change it.
Makes sense. Thank you.
Uh,
Yeah.
so save, and then let's see if this works. Great. By the way, something else which I said that we're printing stuff because it would be interesting to check the logs. This is something really cool about also, like, I mean, the entire AWS ecosystem, which is CloudWatch. So CloudWatch allows you to check pretty much anything which is happening in terms of your application. Logging happens in CloudWatch, and so in here you can there you go. See, there you go. So here is basically I was printing the event, right? Remember here? Where is it? Print event, right? The event is nothing else than this guy, right? And so CloudWatch prints that. So this is incredibly powerful, right? Because, well, think about this. So whenever users interact with this application, now, if something goes wrong, how am I supposed to know what went wrong, right? How am I supposed to know which part broke, right? You have these services interacting with each other, so you really have to have another service with which allows you to dig deeper into those applications, right? And CloudWatch is your way to go, right? So it's incredibly powerful. Anyway, so let's close this one and move to, as I promised, API gateway. So we'll create a yeah. So let's create an
So
API.
just to make clear that as well, everything that you print or log with the logger is going to show up there on CloudWatch automatically.
Yeah, exactly. Yeah.
Nice.
Yeah. So it's really nice, I guess. So we're gonna build the REST API, and then I'm gonna call it demo. Endpoint, yes. New API, create API. Okay, and now I am gonna create a method, which is the post method. I'm gonna say yes, create a post method, and then see. Like, he's asking me, okay, what do you want to do with this post method, right? Well, I say, I want to integrate it with Lambda. So I'm gonna type Lambda demo, right? That's the Lambda which we set up earlier. Use Lambda proxy integration as well. Which I don't recall exactly what it does, but it's fine. Save, and we're gonna now it is telling me, okay, dude. I mean, you're about like to invoke Lambda. Is that exactly what you want? And I say, yes, that's exactly what I want. So there you go, Lambda demo. So now if I go here and I refresh, I should see the trigger appearing. There you go, right? Now we have the API gateway, which we just created, invoking Lambda. And we can test it, of course, right? Now, if I type Francesco, now Lambda is going to wrap everything into a JSON, right, with a body. So I don't have to do it, right? I don't have to actually type body and so on and so forth, right? So that's done by Lambda by default. But let's check if this runs. And bam, there we go. Hello from Francesco. Okay. So now we have a way of invoking this function, which I think is pretty cool, isn't it? I know it's cool.
Yeah.
And all right, so that's basically it in terms of like the interactions, right? So we said that we had where we are. So we started with VisualNeurons.com, and now we're kind of explaining how we go from JavaScript API gateway Lambda. We implemented a Lambda from scratch and invoke it with API gateway, which is the way. The way our web applications are should be running. And now let's complicate things a little bit.
So let me ask a question before we go there.
Yeah.
So right now what's happening there, you're saying that the Lambda layer is going to wrap your request there, Francesco, that you just showed us the test, into a body on a JSON, right? So basically what you have here is basically a big string, right? Can you also send multiple arguments to Lambda? Is that possible?
Yeah, of course. Like it's just a JSON. So this is a test, but again, like it's entirely up to you of how to wrap your code. So it's you have to as long as it is handled by the Lambda handler, as long as it's handled by Lambda handler, it's just going to work. So you have to wrap it the right way in here, so like this, right? So for instance, let me give you another example of wait, home, and then style transfer, right? The fast way. Now, look, what I'm sending here instead, I'm sending the data, so that's the image, right? And I'm sending the style, of course, but I need to know the style, right?
Yeah.
So indeed, I can run multiple. I can send multiple fields, right?
But does this get like wrapped into another field called body? This is what confused me there.
Good point. Yes, it does. It does, and we can check this out. Let me see. I think it's fast style transfer. So that is the function. So this is the function we're looking at now. Is what is what we just saw. Let me see. Yeah.
Ah, okay. So you have a body, and then inside this body you have like other keys for the style and data.
Yeah, exactly.
Okay, yeah.
See, and then I access style, I access data, right? But yes, everything is wrapped around a body.
Perfect. Yeah, thank you. That was it.
But yeah, by the way, so this is like the function which we are calling for. You know, I'm skipping ahead, right? But you know, it's what I wanted to show is the following. So what happens if we do this? If we do import numpy, and we test again. Ouch! All right, that didn't really work. Oh wait, no, there's a syntax error. Oh, interesting. How's that?
Yeah, good question.
What's that? Var task, Lambda functions.
Okay.
Okay.
Yeah.
Okay. Good. Uh, no module named numpy, right? So, well, now this is a problem, right? Because you say, okay, dude, I mean, you just showed us a super crappy function which just prints hello from Francesco, right? This is the most useless function ever. So if I want to do some useful stuff, I need more libraries, right? So how I'm gonna handle those libraries? And this is where it gets interesting. So you have two ways of handling additional libraries in Lambda. And the first one is called Lambda Layers. So a layer is what we are using in the style transfer application. So in this guy over here, right? Which, by the way, I can show you how it works. This is basically running, and then we run a slide transfer, and then we should get a photo of myself pictured as what is this? Kandinsky? I think it's Kandinsky. Yeah. So as I said, there are two ways of handling additional libraries in Lambda, and the first one is layers. So what is a layer? So a layer is a zip file, literally. So what you basically can do in Lambda is you go to your local machine. You literally, oh, there you go. You literally zip. Okay, fun is over. We can get back here. So you can literally get back, go like to your laptop and check like the numpy folder, literally. So the one which was installed, like if using Conda, like Conda site packages numpy. You really go there, you package that numpy folder with everything which was compiled inside. You create a zip folder out of that, and then you upload to Lambda, and that's it. And you basically tell Lambda that you want to use that kind of zip file, which they call layers, right? So in this case, I needed a lot of libraries, right, which are not available out of the blue from Lambda. I needed torch vision, and there's torch, numpy, you name it, right? It's gonna be a nightmare, right? How you do that? So the idea is that you can create those layers, zip everything into one of them, and upload the layer to the zip file to zip folder, sorry, to Lambda, and then import it in there. There are constraints here. Your zipped file, your zipped folder, which is a file, can be lower than needs to be lower than 50 megabytes, and when unzipped, it cannot be higher than 250 megabytes. So that's it creates some challenges because Torch plus Torch Vision plus NumPy plus everything else, I think surpasses 250 megabytes. So there are some tricks to get right, but that's in a nutshell what happens, right? So this is option number one. So option number one, Lambda Layers, all right, which is what I'm using over here to import Torch and Torch Vision. Option number two, well, guess what? Docker, right? Which brings us back to the original Lambda function I was showing. This guy over here. So there's no code in here, right? We cannot see anything. It's a little disappointing, as I said, but that's because everything is wrapped inside this Docker image. So specifically this guy, the IceVision image. So this is not really telling you anything interesting, I'd say. So probably to show you exactly what I mean, let me show you what is packaged inside this image. All right, so inference Lambda. So first you need a Docker file, obviously, right? And the Docker file I use, I think it's IceVision. There you go. So this one.
Sorry, can you increase your font size?
Yeah. That's a good point. Good point. Zoom in. Oh, is that okay? A little bit more.
It's okay for me. Anyone else here? For me, it's fine.
Okay, I'll assume it's fine.
Mm-hmm.
So this is the Docker file for Lambda. So for that image which I uploaded to Lambda. So according to the documentation, first, this was announced 2 months ago, so at the beginning of December. So it's relatively new. AWS documentation is generally very bad. It's, if not completely awful. So it's a little bit of a nightmare to figure out exactly what you need to do to get something to work. But we're not here ranting. We are here to explain how this works. So the idea is that in theory you can use any image you want, really, base image you want here, really. So here I'm using this prepackaged public AWS image as a base image, just because, as we will see very soon, it needs to contain the Lambda runtime. So by needs to contain the Lambda runtime, I mean that if I want to test this Lambda, I need to have some sort of way of invoking the Lambda locally, right? Now, if you noticed, I don't want to sound too confusing, the paradigm is shifting here, right? So we're moving from developing the Lambda on the console, right? Which this is exactly what we have been doing so far, to starting developing locally, right? And so this kind of changes more or less entirely how we're going to attack the problem, right? Because how are we going to test this, right? Shall we every time we need to change, or every time we need to test something, do we need to upload the image to AWS? This is a yes or no, unfortunately. But anyway, so to cut it short, AWS runtime is a little set of routines which allow you to test the image locally, which is why I decided to start from here. And then it's nothing fancy. I'm just installing the requirements, which are Torch Vision, and wait, where is it? And somewhere there should be IceVision. Oh, there you go, IceVision. Okay, then I'm copying copying the model directory, and of course the app.py, right? This is actually the Lambda function, right? That's what I need to call, and which specifically is not this one, but this one, right? So this is the actual Lambda function which I am calling, which we are invoking when we hit this button, right? When we hit this button here, that's what we invoke. Okay, so that's this guy, and specifically the handler in here. This is what we invoke. Okay. All right, so that sounds nice. How do we go about it? So I guess that something we should try is to, well, do it, right? So let's build an image and check how this works. So I had a demo. So this is the Lambda function, right, which we are going to package into an image. And this is the Docker file, right? That's the exact same Docker file which I had before. It's probably a kind of an overkill because I don't need torch and torch vision in here, but it's okay. I have cached the stuff. So wait. So let's try building this thing, right? Docker build. So we are in the right one, I guess. Oh, yep. Docker, IceVision. No, let's call it demo.
Is it also possible to increase the font size here?
Yeah.
I think Mac is a little bit annoying actually to increase the font size. It's okay if it's not. Yeah.
Profile, script, session, view, what the heck? Wait.
Yeah, don't worry. I think it is not so straightforward.
Oh, there we go.
Oh, okay.
Pinch zoom. That's what I guess it would. Anyway, so while we were chatting, it starts building, right? So this is gonna build like the image, right? Which is basically just in a matter of installing the libraries, right? Everything we needed, and then pack everything into. I mean, pack an application. So the actual Lambda function, which is nothing else than this, right? And that's it, right? And then telling the image that when we invoke it, right? If you allow me to say that, it needs to call app.handler, right? That's what we want. So all right, so this is building, and I really should have not removed all the cache. This is gonna be quick, hopefully. Do you have, does anyone have questions so far?
I think I myself has been asking as this goes. And anyone has questions? If someone has questions as well, feel free to type on the chat. Go ahead.
Sorry. Francisco, do you have an idea why the image is so big? The 3 gig, I guess it was 3 gigabyte or?
Yeah. I think I don't know. I think that's because of probably there are in IceVision there are lots of libraries which at inference time they're not actually needed. Right. That's probably the case. But I think like we already discussed that on the forums. Like I've been on Discord. I think
Yeah.
it would be like super interesting to trim it down as much as possible, right? Because well, in some cases you don't need like 3 gigs of stuff. But I'm also like starting torch vision. Those are kind of definitely like a little bit heavy. Definitely it should be lower than 3 gigs for sure. For sure.
Do you have an idea what's the size of the base image of the?
Oh, I don't know. That's a good question. I don't know. What I know is that Lambda allows you to upload images which are as big as 10 gigs.
Okay.
So in theory, you can go wild, right? So I don't think it's like good practice to create like such big images, but
No.
it's up to you.
And you have access to the Docker file definition of their base image?
I think yes, because it's public. It's public. We could
Okay.
check that out later, for sure. They made it public. Okay, great. So
Perfect.
so there you go. We should have it demo. Yeah, there you go. It's built 3.3 gig, right?
So I guess that cold start problem you're talking about is related to this, to the Docker image building on the server. Is that it?
No. The cold start problem is due to the fact that so it's basically when you invoke this a function, right? So you have to think that of course, like you think that it's serverless, right? But obviously there is a server running it, right, somewhere. When you invoke it for the first time, Lambda, I mean AWS and Lambda need to fire up a machine and then prepare the environment for you, right? So like importing the libraries and making sure that if you requested Python 3.8, Python 3.8 is there, this kind of stuff, right?
And it has to install it as well, right? You have to, like all the command that you run right now, it has to do there on the machine. It just got hold as well, I imagine.
Yeah. But yes, but like literally, so it's literally a matter of like at least from the AWS side, like you have this this overhead of deploying the machine, right? So now they have a very smart way of handling machines in the sense that, as I said, like you have like this cold start problem because it happens the first time, and then the second time, if you reinvoke the same function, let's say 3 seconds later, they won't like kill the machine. Like they will keep it warm for you, right? So that if you invoke it again, like the environment is there and already up and running, and we should have it. I think it's more visible in here for the fast style transfer. The fast style transfer application clearly shows this cold start problem. Now let's see. I'm not sure if they already killed it, but like again, the first one is relatively slow, and then the second one is definitely fast, exactly for that reason, right? So they tend like to reuse like those machines, right? Obviously, they don't want like to rebuild everything from scratch at every single time you invoke the function. Now this is the first time, right? So again, it's gonna take a while. And this it can be a problem, right? Again, I mean, for large traffic, I mean, in terms of like if you have like an application with a lot of traffic, I don't think it's like kind of a big problem because your first user is going to experiment that, but then at some point you're going to run very smoothly, right? Because like the servers are warm and up and running. Okay, this is taking a little bit too long. Okay, there you go. Now, if I change the style and herring dance, there we go. And then I faster and transfer again. Bam. See?
Yeah, it's much faster.
So that's the cold. This is the cold start problem, right? So it already had the environment up and running, which makes you understand that the speed, right? It's literally not Python running, right? Python running is really fast at the end of the day. So the speed, the fact that you're waiting for it, it's because the model needs to be. I mean, the environment needs to be set up.
All right. Yeah.
Okay, and then what we can do is that we can run a container on top of it, right? So let's see. This is not IceVision. This is demo. Okay, good. And we should have a container running. Yep, there you go. And then this is the AWS Dark Magic. Well, I mean, it's not dark magic. We make a post request, right? To Lambda. That's basically exactly the same as we did with the API gateway, exactly the same as we did with a test, right? Clicking that button, and we're sending an empty payload. Okay, that's what we're doing. So the service is running, and then we can try running this, and bam, there you go. See? Okay, probably you don't see.
Interesting. Yes, yeah.
Okay. But that's it, right? So that's basically it means that it's working, right? That's cool. So we have packaged a Lambda function inside Docker image, and then the next steps, which I'm not gonna go through, everything is listed in here in this blog post. The next step is to upload the architecting Lambda, write your Docker file, test your build the image locally, check what is going wrong. That is something I didn't touch upon. I will do this really briefly now. But then what what is left is pushing the image to Amazon ESR, right? So ESR stands for Elastic Container Service, which is this guy. And then you upload it here, and then you can, getting back to Lambda here, I can say, yo, I want to deploy a new image, and then he's going to ask me, okay, which kind of image? You select the repo, and then there you go. You got all your images, right? So you can select your image you want to run your Lambda upon, and that's it. So something really painful, which you have to keep in mind when running Lambda, when writing at least Docker images for Lambda, is that Docker does not have write permissions. Sorry, Lambda, or at least like the user which is running Lambda does not have write permissions on the system. So I had quite a bit of a hard time for IceVision because, well, not because of IceVision fault, of course, but because of this. Let me show you core. No, it's not in core. Is in imp. No, it's in core. Wait. No, wait, I can't find it.
Oh, it is utils, utils and data dir.
You're right.
Yeah.
Data dir. There we go. This is the one. So this is the function which gave me a hard time, because it is trying to create directories. So my first attempt with Lambda failed miserably because of that. Because Lambda was trying to write during at import time, as Vision was trying to access the file system and was trying to create a directory, and that didn't really work out. So you have to know that you don't have a write permissions. So you have to make sure that whatever you're doing, you're not. You can write to TMP, I guess, so a specific folder, but you don't have like sudo write access to anything you want. So that's something which you have to keep in mind. And the very annoying part, which I also highlight in the post, is that the test, I of course tested my function right locally, as I just showed you, right? And when I tested locally, it worked. So I complained with AWS, asking them why the heck they would not. They would like why the heck like would Docker break on the AWS console, right? So the whole purpose of Docker is that it should work anywhere, anytime, and this is apparently not the case. But anyway, so they told me that they don't really know.
Yeah, nice.
Yeah, that was it. Another comment which I also receive,
I
quite
have
often.
one question. In your when you invoke your Docker locally, what is the path you write? 2015 dash.
This guy?
No, no, no. In your in the shell when you invoke the service.
Well, when I invoke, so like, do you mean where this is writing?
No, no, no.
No, the endpoint. The
Yeah.
endpoint that you invoked when you
Oh,
run
okay.
Why
your
it has that
container.
path?
Well, like, you mean why it has this path over here?
Yes, the 2015
Oh,
03
yeah.
31.
Very good
That
question. I don't know.
What?
Like this is coming. This is coming from AWS documentation. So I think that they
Okay.
have like yeah, it's a very good question. So like how did I come up with this very weird URL? And the question is that I didn't. AWS did. And it.
Yeah, interesting.
So this is I guess that's the way to invoke your functions locally, right? It's really weird because why would they
Yes.
why would they have like this? I don't know. Like it's a weird organization sometimes.
That is all.
Yeah, exactly.
Yeah, for some reason I think they did this in 2015, right?
I don't know. Yeah,
Yes.
someday. Yeah, 2015. I don't know.
The
Whatever.
guy retired on that
Yeah,
date, and
probably.
then he's not maintaining anymore.
You're joking, but it's very possible.
Very possible.
Okay.
Switch teams, and then he didn't document it, and then these dudes are stuck with 2015 0331 for the rest of their lives. So
Okay.
something else which I wanted to mention is the fact that you might have noticed that there is no way to access the code in here in the console. So what happens if you make a typo, right? So what happens if, well, you might say, well, you tested it, so you shouldn't make a typo. So that's probably not a good example. But what happens if I have something and then I need to import and just edit the function, right? If I need to edit the function, unfortunately, I have to go through this mess again, right? So I have to rebuild the image, I have to test the image, re-upload to ECR, redeploy. I also reached out to AWS asking them why, if there was like an easier way of doing that, of handling this, right? Also, it sounds a little bit cumbersome to me, but they're looking into it. For the moment, you don't have much of a choice. So you have to edit locally, build your image, test, deploy to, push the image to ECR, deploy the image to Lambda, and then if after 2 minutes you realize that you forgot a comma somewhere, you have to redo it again.
Yeah, that's quite a pain. And they don't have like a client that you can use on your terminal or anything. You have to do it through the web app.
Apparently not.
Huh.
But my
Okay.
experience with AWS is that when they launch services, they launch them like the bare minimum, right? So that it works. It could work a lot better, but it just works, right?
I
And
see.
then if they see that the service gets traction, then they improve it.
Yeah, makes sense. Yeah.
Hey, Francesco, where do you load the model? Is that, do you embed the model in the Docker image, or
Yes,
are you
yes,
loading
that
that
is
from
correct.
upstream?
That is correct. So I have the model. Let me close stuff.py. Lambda. Okay. There you go. That's the one. So I basically copy this directory, right? Which is this directory with the model, the saved model. And then within the application, there you go. I load it. Where is it? Oh, yeah, there you go. Here.
How big
Right.
is that model?
Yeah.
Is
So
is that model big? Is it like 100 megabytes?
I think 100 megabytes, something like that. Should be around that size, more or less, around the 100 megabyte. But again, you can go as high as 10 gigs for the image, like the Docker image. So I guess there is flexibility, because that's also like a big point. Something I didn't mention, and for layers, right? Remember this this guy, right? Where is it? Faster transfer. Okay, so this. Oh no, not this guy. Hugging face. Transformers. I was playing around with. Oh, there we go. So in here, like what I was doing is that I basically deployed this steel GPT model, right? Which is what you can find here. It's not working anymore because it was costing too much money, because it was not on Lambda.
Interesting.
So I disabled the feature. But anyway, long story short, what I wanted to say is that I had to download the model, right? So the distilled GPT, which is like the smallest model on 2 years ago, it was the smallest model on Hugging Face, and it was like the weights were 350 megabytes, right, of that model. And unfortunately, Lambda allows you and they give you like a disk space of 512 megabytes. So that was before Docker. So if you had to save stuff, if you have to download from the internet temporarily, you had 512 megabytes of space to use, right? And so that made Lambda unusable for me in this specific context, because I had to use, I had to import Hugging Face, Torch, whole Hugging Face dependencies. I had also like to download that 350 megabytes, and the whole of it was a lot more than 512. Right. So what I was obliged to do, I was obliged to, as you can see here, maybe you can see, I actually use Lambda to fire up an EC2 instance. Okay. So I don't want an EC2 instance to be up and running 24/7. Right? So what I do is that when the user, what I did at least before, what the user did was like it clicked the button, the button, so the button clicked, triggered the API gateway. API gateway triggered, actually I have an example here. API gateway triggered Lambda, and Lambda triggered EC2. So I fired up an EC2 instance, and as you can see in here, that's what I do. See, this is myself. This is what I do inside like the EC2 instance, right? So I basically ask like to shut it down after 30 minutes automatically, and I run a script, right? That's what I do.
Very nice, very clever actually.
I actually write to DynamoDB as well, because where is it? It's in here to show you the AWS diagram. Okay, there we go. Pre-train. What is this? Just go down. Okay, please, thank you. Okay, there you go. This is the AWS diagram, right? So so it basically, again, like AWS API gateway triggers Lambda, Lambda triggers EC2, waits for it to write to DynamoDB, reads from DynamoDB and returns to frontend. In a nutshell, this is what it does. But yeah, so that's it. That's like to address the point which was addressed before. So like the size and how are you gonna handle this? They were planning to increase the size to 1 gig from 512 megabytes, which would be a lifesaver for a lot of people. But yeah, it's not happening right now yet. And that's it. I'm not gonna address this guy. It's already 1 hour, and I think that people are probably either they already fainted or they died slowly. So I think that this is probably gonna be like a separate session if we want to have a separate session.
Yeah. Mm-hmm.
And that's it. That's it on my side.
Very nice.
Do you guys have questions?
Yeah, exactly.
Any other question that we didn't cover, or?
I have a little question. So when you use Lambda, what will you're going just to pay for the storage of your Docker image? Is it correct?
Yeah, you pay for actually when you invoke Lambda, you pay for storing the image on EC2, sorry, on ECR, but that's tiny, right? I mean, you pay technically you pay it 24/7, like because the image is up, it's in there 24/7, right?
Yeah.
Technically, what you get billed for is just the execution time.
You're not billed for the fact that you are storing on their at AWS your image.
You are, yes, but that's not part of
Okay.
Lambda, right? It's like I could, if I was crazy enough, I could upload 100 images here, right? And I could pay for all of them, right? But to give you an understanding of how this costs, how much this costs, I think it's also interesting to build. Okay, this is February. We should go for January. ECR, where is ECR? Elastic.
It's in the middle. Yeah. No.
Wait, no.
A little bit up. EC2 container registry.
Oh, there you go.
Yeah.
Yeah, you're right. So see, that's how much I paid. I mean, I didn't because I have credits, but
Yeah.
it's literally 57 cents.
Okay,
So I guess it's okay.
that's the cost. The cost of the.
Of hosting the image on AWS.
Okay,
Yeah.
and invoking if you
Yeah.
invoke it like now and then.
Lambda.
Okay, Lambda is separate.
Yeah.
Okay,
But because
yes.
see, I have like 1 million requests in the free tier, and it's not. I'm not even close to that, so I'm not even paying for it.
Okay.
Wow, that's really nice.
Yeah.
Hmm.
Well, but that's not nice. Look at this.
Oh, SageMaker, you're paying some stuff.
Yeah. So I to train that model, I used 20 hours. Not because I trained for 20 hours, of course, but you know, I had a notebook up and running for 20 hours on a P3 2x large image, which costs $4 per hour.
Hmm.
So you do the math, and you know.
Wow.
So you gotta be careful. You gotta be careful.
For which model? For the
For the
one of
LaTeX one, yeah, for the LaTeX one. But it's not. Again, I didn't train the model for 20 hours. It's just that the nice thing about SageMaker is that you can have notebooks, right? So you basically train your models on notebooks if you want. They have also a Python SDK, you know, blah blah blah. But what I like is that you get a notebook, right? So I can start this.
SageMaker is like collab.
Yeah, that's it. Yeah,
yeah.
but it's just that you pay for it.
Yeah.
Yeah,
So
subtle
ho-
distinction.
how many images you are training there?
A good question. Oh, no, I know. The 10K.
Okay,
10K.
because I was
So,
wondering, would it be possible to do it just in Colab or Colab Pro?
oh yeah, for sure. Yeah,
Yeah.
absolutely. I was,
So then
yeah,
it will be a lot cheaper than.
yeah, totally. I just wanted to test a couple of features, a couple of new features on SageMaker. That's why I went for SageMaker. But
Okay.
His credits were expiring, right, Francesco?
the what?
Your credits were expiring.
Exactly. Good point. Yeah. So, but yeah. That's a good point. So here, basically, you're starting takes a while to start the notebook. But as you can see, basically you have notebooks, right? And then you can you can tell Amazon, like AWS, where you want to run your notebook, right? So those are all different instances, right?
Mm-hmm.
So technically you cannot choose that on Colab, right? So here you can have like a more powerful CPU, a lot of RAM, less RAM, lots of GPUs, and so on and so forth, right? And this is like the literally just a notebook. What I launched, which is kind of cool, is also SageMaker Studio, which is like an integrated, just an IDE, but it's really cool. It's based on Jupyter Lab, and there you can basically change your environment on the fly. Because the problem here is that when this is up and running, you cannot change it, right? So you can say, oh,
Mm-hmm.
okay, I am training. Let's say that I train for 2 hours on P3 2x large, but then for the rest I just need a crappy CPU instance, right, to run my analysis.
Mm-hmm.
You cannot do that, right? But you can in SageMaker Studio, which is really cool. It takes a while to launch, but it's really cool. This takes a while also because I'm installing stuff. Um,
With with SageMaker, you can you choose like instances that are preemptible, which is a lot cheaper than.
Good question. I'm not sure. I think
Okay.
so. But I'm not entirely sure. But this is taking a little while also because I am installing stuff. See,
Mm-hmm.
so this is at start time. Because again, like those machines they're not allocated to you. They get reused. So if I kill the machine now and I restart it in 10 minutes, I'm not gonna find the library anymore.
So it's similar to Colab, right? That we have to install every time.
Exactly. And so the way AWS addresses this problem is with lifecycle configuration scripts. This is how they're called, and this is one of them. Okay, so this is Studio, for example. Let's see if this is running. I didn't want to get here. I thought that we've been talking already for 1 hour, and so I apologize for the people who are dead. Poor part.
I think even the dead are enjoying.
Awesome. But yeah, see. So now I am in Jupyter, like that's Jupyter Lab, and what I can do is that I can select the kernel, right? And no data science. For example, this is also something really cool. I can select. I can use an image, a Python image, a Docker image, to create a custom environment, and select, and then you can. Let me do this. Not yet. Kernel starting. Oh, here, and then you can select the machine. Right? See, it's kind of cool. So
yeah, it's really cool actually. Really nice. I didn't know about this.
And after 2 hours, you can change it. And that's how I trained. There you go. It's in service. I can open Jupyter, and this is like a very standard Jupyter instance.
And how does the storage works there? You have like a place you can write stuff?
Yep, yeah, you can select IceVision. You can select it at see, I wanted 50 gigs, so they give you 50 gigs.
I see. And when you are selecting the kernels there, they share the same volume?
Yeah, that's like SageMaker Notebooks is different than SageMaker Studio. So they're not sharing stuff. For SageMaker Notebooks, you have a volume per notebook, right? So what you can do is that you can, for example, create notebook instance, and here is gonna ask you, see, volume size in gigabytes. You can go to up to 16 terabytes.
Gotcha.
And yep, so that's it.
Really nice. And just like another question on Studio, on SageMaker Studio, you have a shared file system between the kernels that you have there.
Yeah, that's correct. Yeah.
Okay.
Which is why you can switch from one kernel to another, because the file system is always the same. So you're okay. Technically, you're gonna lose the variables, right?
Yeah.
But then if you save stuff, then you can right, you can just take it from there.
And then you just pay for the kernel you're running.
Yep, that's correct. Yeah.
That's really cool.
Yes.
Yeah.
And that's it.
Any more questions, anyone?
Just when Docker image is launched, that time also takes part of the execution, I guess.
Sorry, say that again. So what is the
first time the function is executed and Docker is launched, that time is also taken as part of the. Okay.
Yes.
Okay.
That is correct. Yes.
All right.
Yep. So let me close this off. So IceVision.
So thanks a lot, Francesco, for yet another presentation. Really interesting. I've learned a bunch of stuff here. And I've got really interested in SageMaker at the end there. So maybe in the future we can make a presentation about that. Yeah, that would be nice.
Yeah. Sure. Yeah, it would be nice. But yeah, so now you know everything about serverless. So go and build stuff.
Yeah, let's go, everyone. Yeah, build stuff.
Yes. Yeah, it was a real pleasure for and if you have questions, just ping me on anytime on whatever channel you guys prefer, and I will be more than happy to assist if you guys have additional questions or anything else.
Yeah,
right.
I think what you can do
here, much, Francesco.
Just we can post like some information about yourself in the chat here, like your blog, your Twitter, and you can show here as well, like what's your blog and your Twitter, and any social media you would like to share. So I think that would be nice.
Yeah, sure. You mean right now, or?
Yeah. So just show quickly, like, this is your blog, this is my Twitter.
Yeah. So that is this very slow blog you are looking at right now is mine. So yeah, that's where I generally write whatever experiments I do. Like I try to blog about them. That is if I had to give a piece of advice to people, I would generally just build a blog. It is incredibly powerful as a tool for job hunting specifically. It works really well. So build a blog, and then on Twitter and LinkedIn as well. I am reachable anytime. So that's my funny face over here, and my funny face again over here for Twitter. So yeah, that's it, folks. So it was a pleasure. Thank you for having me, and I guess to the next time.
Yeah, thank you a lot, Francesco.
Like
Bye-bye.
nothing's ever broken, and I pretend that we are there.